Hello everyone. In the previous lecture, we have introduced the odometer test and the compressibility parameters based on EP curve. In this section, let's discuss compressibility parameters based on E-log P curve. The odometer test results can also be plotted on a semi-log scale. It can be seen from the figure in the majority of the range of the pressure applied on the soil. The E-log P curve is approximately linear. Therefore, the slope of the linear portion of the E-log P curve is designated by the compression index Cc. It can also be used to estimate the soil compressibility. The larger the value of Cc, the steeper the compression curve, and the higher the soil compressibility will be. The compression index is a constant within a majority range of the applied pressure. In odometer test, after a certain pressure is applied to a specimen, decrease successively pressure. The expansion or unloading curve can be obtained. If the pressure is then reapplied incrementally, we can get the recompression curve. Expansion curve and recompression curve constitute a heteroscedastic loop, which indicates the soil is not a fully elastic material. The average slope of the expansion curve and the recompression curve is called the expansion index or recompression index. In fact, the expansion and the recompression curves can be used to reflect the stress history of soil. For example, for a given soil A, if there is no unloading in history, AB line represents the process of a natural deposit. The heat of soil is Z1. The vertical effective overburden pressure is sigma S. BC curve represents the sampling process. The soil rebound due to stress relief. The CD is the laboratory compression curve of soil A. For a given soil B, which had experienced unloading in history, AF line represents the process of a natural deposit. The heat of soil is Z2, and this time, the vertical effective past pressure is sigma P. Then, if the soil B is subjected to denudation along the rebounding curve Fg, the heat of soil layer varies from Z2 to Z1. During the soil sampling, the existing effective overburden pressure is also released, which results in some expansion. When this specimen is subjected to an odometer test, a small amount of compression will occur when the applied effective pressure is less than the maximum effective overburden pressure in the past. When the effective pressure on the specimen becomes greater than the maximum effective past pressure, the change in the water ratio is much larger, and the E-log P relationship is promptly linear with a steeper slope. For further discussion of the effect of stress history on the soil compressibility, we define the pre-consolidation pressure, designated by sigma C prime, as the maximum effective past pressure experienced by the soil. If the present effective overburden pressure is the maximum pressure to which the soil has been subjected in the past, the soil is normally consolidated. If the present effective overburden pressure is less than that which the soil has experienced in the past, the soil is over-consolidated. For newly deposited soils or artificial hydraulic fields, the consolidation and their self-weights has not been fully completed, and a part of the export water pressure has not been dissipated. This type of soil is under-consolidated. Moreover, we can define the ratio of the pre-consolidation pressure sigma C prime to the present effective overburden pressure sigma V prime as over-consolidation ratio. When OCR is equal to 1, the soil is normally consolidated or under-consolidated. When OCR is greater than 1, the soil is over-consolidated. In order to determine the stress history of the ground soils, the pre-consolidation pressure should be firstly determined. In 1936, Casgrande proposed a simple graphic method from the laboratory log peak plot. The procedure is as follows. Step 1. By visual observation, establish point A at which the log P plot has a minimum radius of curvature. Step 2. Draw a horizontal line AB. Step 3. Draw the line AC tangent at point A. Step 4. Draw the line AD, which is the bisector of the angle BAC. Step 5. Project the straight line portion GH of the log P plot back to intersect AD and point F. The emphasis of point F is the pre-consolidation pressure, sigma C prime. Let me summarize. The compression characteristic of soil can be determined by odometer test. Compressibility parameters can be defined based on EP curve or log P curve. Pre-consolidation pressure is applied to express the effect of stress history. Thank you for watching.